Even among alien worlds, Titan, a moon of Saturn, would not be a pleasant place for Earth-like microbes. It doesn't have a global ocean like those on Europa in Enceladus, and it doesn't have Mars's pleasant climate. But in one way, lakes with wavy shorelines dot its surface, giving it a startlingly Earth-like appearance. A molecule in Titan's atmosphere was discovered by NASA researchers. It has never been found in any other atmosphere. Cyclopropenylidene, or C3H2, is a chemical that many chemists have probably never heard of or barely know how to pronounce. This straightforward carbon-based molecule, according to scientists, might be a precursor to more complex molecules that could create or sustain potential life on Titan. Using the Atacama Large Millimeter / submillimeter array, a radio telescope observatory in northern Chile, researchers discovered C3H2. While sorting through a spectrum of distinctive light signatures gathered by the telescope, which revealed the chemical composition of Titan's atmosphere by the energy of its molecules emitted or absorbed, they discovered C3H2, which is composed of carbon and hydrogen. Connor Nixon, who is a planetary scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland, and who led the ALMA search, said, "When I realized I was looking at cyclopropenylidene, my first thought was, well, this was really unexpected." The Astronomical Journal published the findings of his team on October 15th. Although C3H2 has been discovered in small amounts throughout the galaxy, its discovery in the atmosphere was unexpected. This is due to the ease in which cyclopropenylidene can interact with other molecules to produce new species. Astronomers have only discovered C3H2 so far in the gas and dust clouds that drift between star systems, or, to put it in another way, in places that are too cold and diffuse to support many chemical reactions. However, crowded atmospheres like Titan's are frenzied with chemical activity. This moon, which will be the target of NASA's upcoming Dragonfly mission, is of particular interest to scientists for this reason. Because they were searching in the upper layers of the moon's atmosphere, where there are fewer other gases for C3H2 to interact with, Nixon's team was probably able to find small amounts of C3H2 on Titan. Why it would appear in Titan's atmosphere but not in any other atmosphere is still a mystery to scientists. According to Nixon, Titan is unique in our solar system as well. It has turned out to be a goldmine of novel molecules. And if you guys didn't know what Titan is, then let us explain it to you. Titan, the biggest of Saturn's 62 moons, is a fascinating world that is in some ways the most like Earth that we've discovered. There are more than 200 moons in the solar system, more than any other moon. Titan has an atmosphere 4 times as dense as Earth's, along with clouds, rains, lakes, rivers, and even a saltwater ocean beneath the surface. Similar to Earth, Titan's atmosphere is primarily composed of nitrogen with trace amounts of methane. This moon has been elevated to the top of the list by the most crucial targets in NASA's search for current or past life in the solar system, due to the complex web of organic chemistry that's unleashed when methane and nitrogen molecules break apart under the glare of the sun. Rosalie Lopez, a senior research scientist and Titan expert at NASA's Jet Propulsion Laboratory, JPL, in Pasadena, California, said that more about Titan we're trying to determine if Titan is habitable. So, we want to know what compounds from the atmosphere get to the surface, and then whether that material can get through the ice crust to the ocean below. Because we think the ocean is where the habitable conditions are. The same kinds of molecules that make up the building blocks of life on Earth might be present on Titan's surface. Scientists speculate that conditions on Earth could have been similar to those on Titan today between 3.8 and 2.5 billion years ago, when methane predominated over oxygen in the atmosphere. In addition, Melissa Traynor, a NASA Goddard astrobiologist, said she views Titan as a real-world laboratory, where we can observe chemistry that is similar to that of early Earth when life was just beginning to exist here. The trainer will support the deputy principal investigator for the Dragonfly mission and be in charge of an instrument on the rotorcraft that will study the makeup of Titan's surface. The trainer continued, "I'll be looking for bigger molecules than C3H2, but they need to know what's going on in the atmosphere to understand the chemical processes that can cause complex organic molecules to form and rain down to the surface." The only other cyclic or closed-loop molecule besides benzene to date discovered in Titan's atmosphere is cyclopropenylidene. Although C3H2 isn't known to be involved in current biological reactions, closed-loop molecules like it are significant because they serve as the backbone rings for the nucleobases of DNA, the intricate chemical structure that houses life's genetic code, and RNA, a different essential substance for its operations. Another person, Alexander Thalen, who is a Goddard astrobiologist and who has also worked with Nixon to find C3H2, said that the cyclic nature of them opens up this extra branch of chemistry that allows you to build these biologically important molecules. And what we can say is that researchers like Thalen and Nixon are searching Titan's atmosphere for the smallest carbon molecules related to life that they can find using powerful telescopes located on Earth. The complex ringed hydrocarbon molecule known as benzene was once thought to be the smallest unit that could be found in the atmosphere of any planet. But now that it seems to be C3H2, which has half as many carbon atoms as benzene, has replaced it. Nixon combined, through research papers that were published from analyses of data from NASA's Cassini spacecraft, which made 127 close flybys of Titan between 2004 and 2017. Between 2004 and 2017, Cassini performed 127 close flybys of Titan. He was interested in seeing if a spacecraft instrument that detected chemical compounds near Saturn and Titan could support his new discovery. A mass spectrometer, a type of instrument, detected hints of numerous enigmatic molecules on Titan, which scientists are still trying to identify. In fact, Cassini has found evidence for the presence of the electrically charged C3H3 form of the same molecule. Scientists are trying to find out more about C3H3 and how it might interact with gases in Titan's atmosphere because it was a rare discovery. It's a very strange little molecule, so it won't be the kind that you can learn about in high school chemistry or even undergraduate chemistry. According to Michael Malaska, a JPL planetary scientist who worked in the pharmaceutical industry before falling in love with Titan and changing careers to study it, he also added that down here on Earth, it won't be something that you'll encounter. However, Malaska noted that finding molecules like C3H2 is crucial to understanding Titan's larger context. Every little piece and part you can discover can help you put together the huge puzzle of all the things going on there. However, methane-based life forms are still hypothetical as of this writing, despite McKay's 2005 proposal of a set of conditions required for these kinds of organisms to exist on Titan. Although there are liquid water-based microbes on Earth that thrive in methane or produce it as a waste product, scientists have not yet found it as a type of life anywhere. Any organism would need to use a liquid as its medium for living processes on Titan, where the temperature is around minus 290 degrees Fahrenheit. Water cannot function by itself because it is solidly frozen on Titan's surface. Methane and related molecules like ethane are the only liquid candidates on the shortlist. According to earlier studies, Titan has lakes of liquid methane. Finally, we can conclude that all of this speculation is premature. Even though these findings are still far from being proof of existence on life, they might be intriguing. And that's what the scientists have found. Now, I hope you liked the content, and if you did, then maybe you could like the video and subscribe to the channel. Press the bell icon too so you don't miss any of our, content. See you in the next one, and until then, goodbye.